Good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and we are into our multicast course, right? And this is the session number 1 of multicast course. You all know that we just finished, maybe 2 weeks back, we finished switching, and switching is one of the most important concept if you want to learn VXLAN with BGP VPN. Believe me, it is going to be very, very simple. And the second prerequisite of that course is multicast, which we are starting now. We want to go a little bit deeper into the multicast so that we understand this fantastic technology, right? So what is the agenda? Agenda is going to be very, very simple. As you all know, we love analogies. We are going to start this session with an analogy, right? And it is not going to be technical. Believe me, we are going to deliver pizza today, right? I will showcase you that how we are going to do that. But believe me, if you understand this analogy, it is going to take you one step closer towards multicast. We will be talking about why behind multicast, because why or understanding why behind anything is going to be very, very important, and it is the USP of our classes that we understand why behind things. We will be spending good amount of time here. Then we are going to break multicast. What is the meaning? We will see what exactly multicast contains. If we break it, we will find its pieces, and if we learn those pieces, then it is going to be the easy way. And this is our approach of learning. What we are going to do next is we will be understanding an interesting use case of multicast and then some calculation. What are these calculations, by the way? These calculations will definitely prove you that multicast is solving a serious problem, right? And that problem can happen in a specific scenario. What is that scenario? What are those going to be? What are those calculations? We will be doing it. And do not worry, these are not hi-fi mathematics. This is going to be your fifth or sixth grade mathematics, right? And at last, we will be finishing at layer 2 multicast and its importance. Having said that, without wasting any time, let's start with our analogy. And the analogy is how you are going to deliver pizza. Question is wrong. Why on earth you would like to deliver pizza? But let's try to understand the mechanism, right? We won't be using the word multicast, but we will be seeing some of the nitty-gritties of it without taking name of it. So what is happening here is we have colony number 1 here, and it has maybe 5 houses. I wanted to showcase more, but it is going to clutter the diagram. That is why I have only 5 houses here, right? And then we have another colony. Maybe this is colony number 1. This is colony number 2. Again, it is having 5 houses, right? And there is a pizza store here. The responsibility of delivering pizza to these different colonies, right? And is the responsibility of this pizza store. Okay. This pizza store has several delivery boys also, right? So what happens? People order pizza. These guys have delivery boys. These delivery boys has bicycle also, or maybe the motorcycle also with them, and they sit on that and deliver the pizza. It is very, very common in India, right? You see there are a lot of new chains. You see there are a lot of new applications which we use to deliver our food from these restaurants, right? But we are talking about here pizza, and this pizza store has several delivery boys, right? And it is as simple as that. Somebody has ordered pizza, maybe through online or maybe calling them, and this guy sits on a bike, right? And he goes on on this road, and at the Y junction, basically, maybe depending on which society or the colony has ordered the pizza, they go there. As simple as that. Very, very easy, right? So what is the problem? right? Let's introduce some problems. So what is happening here? From colony 1, there are 3 houses which I have showcased you in this yellow color. They have ordered pizza. And similarly, from the colony number 2, which is the orange colony, here also 2 yellow guys or 2 yellow houses have ordered pizza, maybe through any mechanism. And we have a store manager here, right? The cost of making a pizza is only 100 rupees, and these guys are selling these 100 rupees pizza as 200 rupees. And basically, they are earning profit of 100 rupees. It is as simple as that. But this store manager wants that some money actually goes in providing the salary for these delivery boys. And these delivery boys also use a vehicle, which is motorcycle, which runs on gas or the petrol, right? And if that is the case, we need to give the money for the petrol too, as simple as that. So it means that this 100 rupees profit is not 100 rupees profit because they need to give the salary to the staff as well as these delivery boys. So this guy is supposed to be pretty efficient, and he is busy in making the delivery of pizza more efficient. Now, he has received 5 orders. One way to deliver these 5 orders is that he should have these 5 boys or the delivery guys, and these delivery guys have 5 different motorbikes, and these 5 guys goes here, then 3 goes here, right? And 2 goes here, and they deliver the pizza. It is as simple as that. But do you think this is an efficient approach of delivering pizza? You will say no, right? For 5 different houses, if I send 5 different people with motorbikes, then definitely it is going to be extra load, right? It might give us less profit. So this guy is actually trying to make it as efficient. By the way, whatever we just did, right? We are sending a pizza from pizza store to 5 different houses, and we are sending 5 different guys. This is actually your unicast way of communication, right? If we have one host, and if you want to send packets to different 5 hosts or 10 hosts, what we do, we create packet with source IP of this guy and destination IP of this guy, and this packet will be delivered here. Another packet will be delivered here. Another packet will be delivered here, providing the fact that you are sending the same information to this A, B, C, D, and E. It means that you are creating 5 different packets and you are sending them. It means that you are having 5 different streams and you are sending them to 5 different hosts. This is a unicast way of delivering the pizza or the packet, right? And it is highly inefficient with respect to this store manager, right? And this store manager is thinking and thinking again and again how exactly to make this process efficient, and he is busy in this thing, right? He's that much busy, so that means if he's sleeping, right, he is trying to solve this problem in the sleep. And one night he had a dream. And what is the dream, right? He's saying that instead of sending 5 delivery boys, what I will do this time, I will send only one delivery boy. And this delivery boy is an special delivery boy. He has some magical power in it, right? And now you must be thinking that, Mr. Vishnu, why magical power? Because it is the dream of Mr. Store Manager. He can do whatever in his dreams, right? You cannot stop him. So he is seeing a delivery guy who is having magical power. He is on one motorbike and having 5 different pizza placed on the motorbike, and he is on this motorbicycle, and he reached here. at this junction. And here is the problem. What is going to happen, right? So, because this is a dream of Mr. Store Manager is saying that this guy is replicating itself. Very, very interesting. What is the meaning of replication? He's saying that this guy is converted into two human beings. One will be going here and the other will be going here. One will be taking three pizzas and the other will be taking two pizzas. This guy will deliver the pizza in this colony and here it will be deliver the pizza in this colony. Very, very interesting, right? This is the replication mode, guys. This guy can be two guys whenever is needed, right? You must be thinking that Mr. Vishnu, what is the problem if this guy can go first here and then here? Might be in this process the pizza can be cold, right? Nobody like cold pizzas. But it doesn't mean that this guy can replicate itself. But because this is the dream of Mr. Store Manager, he can think whatever he wants. So he wants to solve this problem and he is actually thinking some out of the box solution. So if I say you that can it be possible in the real life, then no, right? We cannot replicate ourselves. As simple as that. But can it happen with the packets? It definitely can happen with the packet, right? We can send only one packet from here to here whenever it is needed to go into separate direction. We can replicate it because at the end of the day, who is going to process the packet? Either it is going to be a router or a switch. We can add this functionality that if a packet wants to go on two or three interfaces, just like this Y junction, this router can just replicate this packet because this is not the human being, this is just the packet. We can have as much as copy of this packet as we want, right? But you must be thinking that under what situations we need to send this packet. Whenever you want to send this packet to multiple interfaces of the router or switch, you need to replicate it. Otherwise, one packet is more than enough. And I'm pretty sure that you didn't get what I said. And if you don't, that is perfectly fine. But you just keep this analogy, right? Keep this dream of Mr. Store Manager somewhere back of your mind because I will remind you. I will remind you after 30, 40 minutes because this is important, right? Let's move to the next board where we will be talking about why behind multicast. And by the way, I have a mistake here. This is not why behind layer 2. This is why behind multicast. Okay. And here we are discussing an approach of unicast delivery. And you all understand unicast pretty well. If you don't, or if you do not understand unicast routing or unicast switching, please have a look at my videos on switching and routing. As simple as that. What we are doing here, we have several IP networks. We have this gray IP network. We have orange, green, blue, yellow, and so on. And we have some endpoints in it, right? If I say endpoint, this is the actual end host. It can be your computer, it can be your mobile phone, right? It can be your pad, or it can be your TV also. As simple as that. At the end of the day, if you connect an Ethernet cable to them, those are going to be part of your network. If they understand TCP/IP, those are part of your network. As simple as that. So what is happening here? This guy, the white computer, is a special computer, and this special computer has a song, and this song is a video song. Interesting, right? A new movie released, and some of the folks in our network are interested in watching this song, specifically the video song. And this guy has this song, right? And let's see who is interested in this song. If we see, then we find that in Orange network, this computer, maybe this is computer number A, and this computer number B, is interested. But C is not interested. It can be, right? Definitely not all guys are interested in all the songs. Maybe only A and B are interested from this network. Maybe in the green network, if I say this is Mr. D, this is E, this is F, then Mr. F is only interested in this song. Similarly, in the blue network, this guy and this guy is interested. Maybe this is Mr. G and this is H, and this guy is not interested. And in yellow network, nobody is interested, suppose, in this song. Very, very interesting. In orange network, only two guys. In green networks, only one. In blue network, two again. Yellow network, nobody is interested. All right. Let's deliver this song, right, into these three networks using the unicast methodology. And what is the meaning? Unicast means one-to-one delivery. Suppose the IP address of this host is 10.10.10.10. It is a part of /24 network, right? And this orange network is having network maybe 192.168.10.0/24, right? This guy is 20.0/24. The starting bits you can write 192 and 168. This guy is 192.168.30.0/24. Suppose it means that this guy is going to have 254 hosts, right, from .1 to .254, and maybe the IP address of A is .10, the IP address of B is .20, the IP address of this guy in this network is maybe 20.10. The starting two octets you can write, which is 192.168, as simple as that. And here, the guy who is interested in this stream is Mr. H, and the IP address is, say, 30.10. What is going to happen? This guy will be creating 5 different packets for these 5 hosts. Host number A, B, right? And then host number H, and then host number simply E and H, right? Whatever. And this is, I'm so sorry, this is basically my host number F. I forgot about it, right? And then here that's 5 hosts we have which are interested in this video song. What is going to happen, guys? 5 IP packets are going to be created. This is my first IP packet. What is going to be the source of this packet? 10.10.10.10. What is the destination? Destination is the first host which is interested in receiving it, which is A, and the IP address is going to be 192.168.10.10. As simple as that. What is the second packet it is going to create? It is going to create the second packet as, again, 10.10.10.10 is the source, and destination is going to be 192.168.10.20, the IP address of host B. And what is going to be the data inside it? This song. Let's assume this song can be delivered into one IP packet, which is not possible at all. We need to create multiple packets, and that multiple packets with these two IP address are going to be known as a stream, because those are part of the same song, right? What about this? This also is going to have the same data, but this data is going to some other machine. This pizza is going to be delivered to some other house. As simple as that, right? Similarly, there is going to be third packet form. What is going to be there in this third packet? Of course, data. Source address is going to be 10.10.10.10. Destination is going to be 192.168. This time 20.10, which is my this host number F. Similarly, 2 more packets, and you can write down it, right? It means that same data needs to be delivered 5 times. It means that if I want to deliver this complete song, which can be part of multiple IP packets, I need to have 5 different stream. One stream is for this guy, number A. The second stream is again going on the same routers. It is reaching to B. The third stream is going to be from here, maybe this path or whatever path, right? It will be reaching to Mr. F. The fourth stream could be like this, and reaching to Mr. H. As simple as that, right? The fifth stream again is going to be like this and reaching to Mr. E. How many streams are we having here? 5 different streams. It is actually like that we need to deliver 5 pizzas, and basically we have 5 delivery boys, and those 5 delivery boys have the responsibility of delivering the pizza into the 5 different houses. It is the wastage of resources. Right now, this is the normal way, right? We do unicast like this. But generally we see that a host needs to communicate to another guy. Pretty less time you see that a host needs to communicate with the same data to multiple times, right? Or multiple hosts. But if we want to do that, if we want to deliver this video song, this white host need to send 5 different streams of data for 5 different destinations. This is the unicast way of delivering the packets, guys. Now let's understand what is going to happen. So this is inefficient way. We have 5 different streams, and see, the same packet is going on these routers, right? Same, right? Although the source and destination is, say, if I'm saying the same packet is going on, means the data is going to be same, because at the end of the day, you are sending the song. If this song can come into, let's say, 1,000 packets, right? 1,000 packets are delivering over this stream. Same 1,000 packets are delivering over this stream. Same 1,000 here, here, and here. What a waste of computer resources. What a waste of networking. And I will show you numerically how many, or yeah, how much bandwidth is losing in this approach of sending your packets to different hosts, sending the same data to different hosts. But it is really, really simple. Now, let's understand another approach which is known as the broadcast. But to understand broadcast, we need to understand 2 different concepts, right? What are these concepts? So you might have heard about a term which is known as broadcast, and the other term is directed broadcast, right? And we need to understand them. What is the meaning of it? So if I talk about broadcast, basically we use this term in layer 2 networks if we are talking about IP networking, right? So what is happening? We have a complete this big network, and in this network we have several hosts. And if you are part of my switching class, then you already know about this concept, right? What is happening here? We have a switch and we connected all these 5 different hosts, which are A, B, C, D, and E, suppose, right? Now, if this guy sends an ARP message, and you all know ARP message, a broadcast message at layer 2, means whatever the information it has with respect to IP, I don't know, or maybe the ARP message. And after that, it needs to put a source MAC and destination MAC. Source can be anything, but the destination MAC is going to be all F. If it is all F, then it is a broadcast. What switch is going to do? It is going to send this message on all the ports except on the one where it was received. As simple as that. This is the layer 2 broadcast, right? What is the meaning of directed broadcast? If you need to understand the meaning of directed broadcast, you need to understand a topology. What is a topology? Suppose I have a router R1, right? And another router here is R2, and these guys are connected like this. This guy is connected with router number R3 also. R1 is connected with a network, suppose. R3 is also connected with another network, and this is very interesting example I am giving to you. Okay. The network number of this network is 192.168.10.0/24. The network number of this network is 192.168.10. Sorry, 20.0/24. And suppose we have some 1020 hosts here, right? And we have some 1020 hosts here. And what are the IP address range for these hosts? You already know that this network is going to contain from .1 to .254, and you can give any IP address to them because two IP addresses already booked. They are used for some other purpose. One is the subnet number, and the last IP address is known as the broadcast address. So what is the broadcast address of this guy or this network? The broadcast address of this network is 192.168.10.255. What is the broadcast address of this guy? The broadcast address of this guy is 192.168.20.255. As simple as that. But what is the significance of this broadcast address? Let's talk about it. Suppose what is happening here, we have this guy R2, right? Or suppose these guys are not connected like this. Sorry for this. If I give you example, maybe R3 is connected like this. Suppose, right? R2 is connected with R1, R1 is connected with R3. And now R2 is connected with a host. Of course, a switch is there, but I am not drawing it. And this host is a specific or special host. It has a song with it, the same song, right? And the IP address of this guy is 10.10.10.10/24. And now, out of these 20 hosts in network 192.168.10.0, only these two hosts, host number A and host number B, are interested. Here, host number C and host number D are interested. Out of maybe you can say there can be 100 hosts here, but only two hosts in network number one, this guy, and only two hosts in network two are interested in this song. Remaining are not. So what this guy is doing, and this is doing an interesting thing, this guy is saying, no, I am not sending four different streams. Previously, 5 hosts were interested in the unicast method, and we were sending 5 different streams, right? Here, this guy is saying, no. That was the inefficient way. What I will be doing here is, I will be actually creating only 2 streams. Very interesting, right? And what these streams are going to have, first thing first, these streams are going to have this song, right? Which is the data, as simple as that. And then we are going to have source IP address and destination IP address. What will be the source IP address? Of course, it is going to be 10.10.10.10. But here is the magic this guy is doing. It is saying, no. I am not sending this message to a specific host. I will be sending this message towards 10.10.10. Sorry, 192.168.10.255. And you all know 10.255 is not any host, right? Because host can have IP address from .1 to .254. Maybe a switch is connected here and everybody is connected with this switch. And you can have only .1 and .254. Then what is this address? What actually is this address? 10.255. Very interesting, right? It means that you are not sending to one guy inside this network, you are actually sending to all the guys. And this address is basically known as directed broadcast. By the way, when you send this packet to this guy R2, what R2 is going to do? R2 will be checking the destination IP address, and then it will be checking its own IP routing table. And suppose you are running OSPF between them, it means that router 2 is going to have a OSPF route which is 192.168.10.0/24 can be reachable via R1. This is going to have this route, and this guy knows that although I have this route, but the packet is not going to a one address. Packet is going to the broadcast network, or sorry, packet is going towards a broadcast IP address, which means that this guy can make trouble to all the guys sitting inside this network with just single IP address. Believe me, if you send an IP packet to a broadcast address, it is not meant for one guy, it is meant for all the guys inside it. So 10.255 is the directed broadcast for this network. Really, really interesting. And by the way, by default, routers are not going to forward the directed broadcast, because this is directed to all the hosts of 192.168.10.0, as simple as that. And I am talking about by default, it is not going to send, but you can change that. Routers can forward directed broadcast if you configure a command into them, right? If you do that, router will start forwarding this. This packet can reach from here to here. If this router can forward the directed broadcast, when it will reach to R1, what R1 is going to do? R1 will see that it is going towards 10.255, which is the broadcast address of my directly connected network, right? It is going to deliver it to switch, and it will say that the destination address of this IP packet, right? And of course, because this is the Ethernet network, you all know now switching pretty well. So if router R1 wants to put this message inside this switching network, it needs to put what? Source MAC and destination MAC on top of it, right? So basically this packet will be having source MAC and destination MAC when R1 is going to be forwarding. Source MAC is going to be R1's interface and destination MAC is going to be all F. It means that once it is delivered to this message, when it is delivered inside this network, this frame is going to be forwarded to everybody. Who has asked for this song? Only A and B. Where it is delivered? It is delivered to everybody. This is the problem of broadcast, right? It is as good as, just take an example of those colonies, right? Those colonies have 5 homes and only two guys were ordered pizza, right? Only two guys have ordered pizza. If that is the case, only two should receive, right? Only two homes should receive. But what is happening? Everybody is receiving the pizzas, right? Although it is a good gesture, everybody will be liking it. But in computer science, if you deliver this message or the song to everybody, nobody is going to like it, right? Although you can discard it, but still, to discard also, you need to process the package. I think you understand the directed broadcast here, right? Directed broadcast means you are sending an IP packet to an IP address, which is the broadcast address of the network. By default, routers are not going to forward it, but you can configure them to do so. But by default, routers are not going, and basically, this is the not by default, routers are not going to take the ARP messages from one network, which is a broadcast message. It is never ever going to deliver to another networks. And that is why we call routers that it is not going to forward ARP messages, right? From one network to another network. People have this confusion. Does it mean that router can't generate ARP? No, we have talked about it in the switching sections, right? Router can generate ARP because it is one of the most important thing routers do, right? Because they need to find out the MAC address corresponding to an IP address. If they want to, they need to generate ARP. But routers are not going to take a broadcast ARP message from one network to another network. But we are not talking about layer 2 broadcast here. We are talking about directed broadcast. And if you get the meaning, let's try to understand what is happening in this picture, right? The same thing. It is actually the same thing. What is happening now? Only this host, and this host is only interested in receiving the song, which is the property of Mr. White host, right? What is going to happen? This host is saying that I am not going to send the unicast message because for that I need to create 4 different flows. You all know about them. If that is the case, it needs to create these 4 flows: 1, 2, 3, and 4, which is going to be wastage on the network. So what exactly it is doing? It is creating a unicast message. Sorry, it is creating a broadcast message. Suppose this guy IP address is 192.168.10.0/24, and now you know what is the broadcast address. The broadcast address is 192.168.10.255. This subnet is 192.168.20.0/24. What is the broadcast? 255. So what this guy is doing, this is creating 2 different packets. Suppose the IP address is 10.10.10.10. First packet, it is going to have the data or the song. The source is going to be 10.10.10.10, and destination will be the directed broadcast, which is 192.168.10.255. This is going to be the first stream. What is going to be the second stream? Let's draw it. The second stream is going to be, it is going to have, of course, data, and then source IP and destination IP. Source is again the same 10.10.10.10. Destination is going to be 192.168.20.255. As simple as that. But what is going to happen now? There will be one stream which will be coming from here to here, and there will be second stream. Let me draw the color pattern correctly. Okay, so first yellow, which is delivered from here to here, and the second is the red one, which is going to be delivered like this and this. Really, really interesting. And now you know. And by the way, what I have done is on all these routers, I have enabled that these routers can forward the directed broadcast messages, because these messages are directed broadcast, right? Because where exactly it is going? It is going to all the hosts of Orange as well as Green network. And believe me, if you have enabled the directed broadcast and if you do a ping to 192.168.10.255, all of these guys are going to be replying. If this network has 100 hosts, suppose, you will be getting 100 replies of your ping message, believe me. But for that, you need to enable the IP directed broadcast here. If you do not, by default, router is not going to forward these messages, right? But what we are trying to do now, we are trying to solve the problems, whatever we are seeing in the Unicast. In Unicast, there were 7 flows for 7 different hosts. Here we have 2 hosts, 2 flows for 4 different hosts. If I was delivering the same thing using Unicast, I would have used 4 different flows. But actually, broadcast is solving a problem, right? On this IP network, I have 2 flows only. That is it. One is yellow one, which is going inside the orange network, and the other flow is the red one, which is going inside the green network. But now what is going to happen on this router? Suppose this is my router number one, this is router number two. Router number one will be sending this message on this interface. And if it wants to do that, then this interface is my Ethernet interface. If this is an Ethernet interface, what do we need to do? We need to put source and destination MAC. What is going to be the source MAC address? Source MAC address will be the MAC address of this interface. Maybe it is CCC, right? So suppose this yellow packet came here, right? And you know the inside content source IP and destination IP. The destination is .255, you all know, right? But what we are doing here, we are putting the source MAC and destination MAC. Why? Because we need to put this packet onto this Ethernet wire, and Ethernet doesn't understand anything except the MAC addresses. If that is the case, the source is going to be CCC, and now this router is going to check what is the destination IP address. It is going to see the destination IP address is 192.168.10.255. It understand it is the broadcast address of this network, because if you understand subnetting, router also does understand this. If it knows it needs to go everywhere because this is the broadcast address, router will put into the Ethernet address as all F. It should go everywhere. When switch receives, switch is going to forward it on this port, this port, or this port. And if there are 100 of devices here, this broadcast message will be delivered to 100, right? But we want to deliver only to 2. And this is the problem of broadcast method. Although on IP network, it is solving an issue, because if it was the use case, or if we were using Unicast, right, there would have been 4 different flows into this IP network. But if we are using broadcast, there are only 2 flows. Definitely we are improving, right? We haven't improved much, but we are improving a lot. It's a 50% improvement. But there is a problem too. In Unicast, we do not have to deliver the packet to everywhere, right? But here, when the packet reaches at the final network, basically what is happening? It is delivered to everybody, and that is why it is the broadcast, right? It's a problem, right? It's a problem if we have 200 hosts. Out of 200 hosts, only 10 were interested in this song. It is going to be delivered to all the 200 hosts inside this network. Similarly, try to understand the scale. If we have 200 hosts here also, router 2 is going to send the broadcast, which is delivered to all the 200 along with the one who are interested in this song. Although for this IP network, it is an improvement, but for the layer 2 network or the switch network, it is a disaster approach. And you all know broadcast is a disaster for your layer 2 network. Just try to think that now, right now, only one host is sending a song. Maybe there are 50 hosts, and there are 1,000 devices in every network, or maybe 200 devices in every network, and we have maybe 50 of such network. It is going to create a problem inside this layer 2 network, because although it is a directed broadcast, but switch does not understand the IP address. It understands the MAC address, and in MAC it is written it should go to everywhere, all F, right? And when switch see all F, it is going to forward it to all the ports, right? We just discussed about layer 2 broadcast. There is some improvement on this IP network, but actually broadcast is not an efficient way in this scenario. Now let's consider another approach, right? Let's consider another approach. And by the way, this is not why behind layer 2, guys. Extremely sorry. This is why behind multicast, right? Again, the scenario is absolutely same. We have, sorry for this, we have this white host right here, and it is having a song from a new movie, right? IP address is 10.10.10.10, and this guy, maybe the subnet is 192.168.10.10, 10.0/24. Here we have 20.0/24. Here we have 30.0/24. And now suppose out of these three hosts, these two guys are interested, right? Out of these three hosts of 20.0 network, only this guy is interested. Let's see. Can we think something else, right? Can we think just like the store manager, right? Because there we were trying to replicate human beings whenever we see a Y junction, right? Which is not possible. But let's see, can we think something like that? Let's see. So what is going to happen? We have only one, we have this song, and this guy knows that four people are interested in this song, right? So now this guy is very, very efficient. What he's doing, he's saying, I will be sending only one IP packet. I will be putting this song inside this IP packet. The source IP of this is going to be 10.10.10.10. And you must be thinking, Mr. Vishnu, what he's doing new? I will say nothing, right? But see, previously in case of Unicast, if you need to deliver to the four host, you need to create four different streams. In case of broadcast, although these streams were reduced to two while they were crossing the IP network, right? There is an improvement, but that becomes disaster in the layer 2. Now what we are going to do here, we are actually sending this message to a destination IP address, which is a magical IP address. I am not defining that, but presume this is x dot x dot x dot x. And believe me, pretty interestingly, all these guys who are interested, they are actually listening on x dot x dot x dot x. How and why that is happening? Believe me, that is the topic of next 10 or 12 classes. But this is something magic happening. And you must be thinking, Mr. Vishnu, this IP address is this network, and this IP address is also in this network, the same IP address. That is why it is magical. But what is the magic? Don't worry, there is no magic. If you understand the logic, magic is not there, right? I I presume that you must have seen a lot of magic, right? Right? Or magical shows. But believe me, if you understand the trick behind it, you will say that there was no magic at all, right? But if you do not know anything about multicast, believe me, it's a magic, whatever is going on. I am not telling about you the magic. I'm just saying that we are sending this song in an IP packet whose source IP is 10.10.10.10. Of course, the IP address of this white host, the destination IP address is x.x.x.x. I am not sure about this IP address at all, but this is a magical IP address. What is happening here, guys? This IP packet is going to reach here, right? And believe me, if I name them, this is my router number one, this is my router number two, this is my router number three. These routers are talking to each other. I'm not going to talk in detail that what they are talking, but router 2 is informing router 1, hey Mr. Router 1, I am interested in any packet which is going towards x dot x dot x dot x. Very, very interesting. Router 3 is telling Mr. R2, I am interested in a packet who is going towards x dot x dot x dot x. This magical, right? And how come on Earth R2 knows that it is interested in x dot x dot x dot x? Because its orange network is informing R2 that there is somebody, there are two hosts at least, who are interested in x dot x dot x dot x. Very, very interesting, right? If that is the case, see the magic here. Actually, R1 is just creating one packet which will be going towards R1. R1 knows that R2 is interested in it. It will be sending it towards R2. Till this point, only one IP packet is coming from here to here. The source is 10.10, destination is all magic. Now see what is happening here. At this point, at this junction, R2 knows that I have only one packet, but R3 is also interested. I have only one packet which needs to go towards my orange network. But R3 is also requesting, right? So what it is doing, it is actually replicating this. What is the meaning of replication? It is creating another copy of this, the same one. 10.10 wants to go to x dot x dot x dot x. It is creating the same copy, guys. And one copy it is sending towards this switch in the orange network. The other copy is sent towards this R3. This is the copy which is 10.10.10 source and destination is x dot x dot x dot x. Believe me. Just try to remember, as I mentioned, that after 40 minutes, I will remind you that analogy. Try to think that we have this guy who was sitting on this bicycle with 5 pizzas, and now it has the Y junction. What this guy is doing, it is replicating himself. One is going here, one is going here. It was a dream of Mr. Store Manager. If this is the case, pizza delivery would be highly efficient, but he cannot do it. It was his dream. But try to understand here what we are doing. We are at R2, and at R2, we are replicating the packet. We cannot replicate the human being, but we can replicate this packet. R2 is doing exactly the same. As simple as that. One towards the orange network, the other packet towards the green network. And to reach the green network, it needs to go towards R3. As simple as that, right? So basically, who is doing that replication? Router, right? Now, let's talk about what is going to happen next. This switch is going to receive this message, right? The IP message. IP message is having source is 10.10, destination is magical. But you all know from the switching classes that basically this switch doesn't understand the IP address. Switch understand MAC, and when this R2 wants to place this IP address toward this guy, it needs to have the MAC address. The MAC address, source MAC address is going to be the MAC address of this interface, right? R2's interface. Suppose this is CCC. I will be putting the source as CCC. What would be the destination? Destination address is again the MAC address, and believe me, the MAC address is again a magical MAC address. Don't worry about this word magical, right? Because we will go directly into it. Sorry, we will understand every nitty-gritties of this magical address, which is at IP address, IP magical address, and MAC magical address. We will be talking about it. Don't worry. And just try to understand when this reaches here, we understood that switch does either flooding. If it finds the packet inside its MAC address table, then basically it is going to unicast it. If it doesn't, it is going to flood it. You all understand from the switching class, right? But here, because of this magical address, believe me, the packet is only going to be delivered to this host and not to this host. This is the power of using this approach of replication. But again, the question should come to your mind, Mr. Vishnu, this was the single packet received by this switch, right? And I'm going to say yes. Then how the switch is going to deliver it to two different hosts? I will be saying that this switch is again doing the same thing. It is again doing the replication. Believe me, guys, in case when switch does flooding, it replicates the frame. It is nothing new to the switch. But now it is not replicating towards every interface. So suppose here we have 200 hosts, right? And out of those 200 hosts, only two are interested in this multicast stream. If that is the case, Switch is going to deliver this multicast stream to only those two hosts, not remaining 198. Believe me. And that is the power of this approach. And by the way, this is the multicast way of delivering the packet. If we are doing at layer 3 level, if router is doing that, we call it at layer 3 multicast. Otherwise, we call it at layer 2 multicast if it is happening on switch, right? See the difference. You are not doing unicast, you are not sending the 4 stream, you are not doing the broadcast also at the switch level because it is not reaching to everybody inside the network. You are doing something more efficient than unicast and broadcast in this case. So suppose if I have a network of 10 different hosts, right? I'm not sure whether it's 10 or not, 4 plus 4, 8, right? And suppose A wants to communicate to B, this is called as unicast communication, right? Suppose A wants to communicate to everybody, it is called as broadcast communication. And now suppose if A wants to communicate to only 4 of them who are interested in the song which is A is having, then this communication is called as multicast communication because you are sending the traffic to group of hosts, not the single one, not everybody, but the group of hosts. Very, very interesting. If you are doing it at that layer 3 between routers, this is known as layer 3 multicast routing or the multicast routing. At layer 2, we are going to see the multicast, which is also known as layer 2 multicast. As simple as that. So if you want to understand this multicast, and if I break it into multiple pieces, you are going to see only two different things. That is it. This course is not going to be super duper, what we can say, intensive. It is very, very simple. 12 classes and we are done. So if I break multicast, believe me, you are going to get only two different puzzle pieces. If you understand how you can deliver a packet inside a switch, so if a switch is connected and switch has several hosts and only this one and this one is interested, then how you are going to inform this switch, you need to make this switch more intelligent so that we do not want to flood, we do not want to do unicast, we want to send the packet to these two interested folks. And if that is the case, the packet should go here and here. Very, very interesting. And believe me, the protocol which we are going to type, going to go a little bit deeper, is going to be your IGMP, which is Internet Gateway Management, sorry, uh, Internet Group Management Protocol, because we are talking about now groups, right? Similarly, at layer 3 level also, a router can decide if a packet is coming, how many interface it can go. Generally, in case of unicast, it goes out of only one interface, right? But we just saw a case, right, where router needs to replicate it. For example, if you see router 2 here, right, this one, when it receives the packet, it is sending the packet towards this guy, right? If I showcase you with the green, right here, right? It means that it is replicating the packet. It means the packet will be going on towards the orange network. Let me take the yellow pen. It is going towards the yellow and it is also going toward the green. So router 2 is replicating it. It is sending the message on two different interfaces, one towards orange network, the other one is towards the green network. So router is doing replication. Router is understanding that this message needs to go out to two different interfaces. If that is the case, router is doing the multicast, and we need to understand layer 3 multicast also. And this is where we are going to learn about protocol independent multicast. Doesn't matter which routing protocol you are running inside your network, it doesn't matter at all. You can send multicast message on top of it, and we will prove you, right? The PIM is of different kind, like sparse mode, dense mode. Want to reach, nobody want to learn dense mode, and why? I will prove you, right? Everybody is going to learn about sparse mode. What is that? We will be talking about it. We will be talking about sources specific multicast also, bidirectional PIM also. Whatever is needed for the VXLAN course, we will be talking about it. But this course in itself is going to be your fundamentals and the solid fundamentals of your multicast. Having said that, let's move to the next board where we are going to talk about a use case, right? By the way, 1 hour is already over. I'm not sure people haven't raised any hand, so they got everything, I believe. But at any moment, if you feel that there is a question, this is the time to raise the hands, right? Having said that, let's understand an interesting use case. What is happening here, right? Let's take example of Mr. Rahul. That Mr. Rahul is right here. He is the owner of Sports India Corporation, which we generally take as an example, right? So this organization sells multiple sporting goods, cricket bat, cricket ball, badmintons, right? Lawn tennis rackets, and so many things, right? And now Mr. Rahul products are famous not only in India, but everywhere, right? And he has a huge corporate building, maybe inside Delhi, and then he has several corporate building, although he has more than 100 offices across the world. But I cannot show you that, and that is why we have three offices here, right? So Mr. Rahul is a big guy now, and he actually has some vision of his company. He want to share how many bonus you guys are going to get. He wants to talk to his employees, right? But unfortunately, or you can say not unfortunately, he has a population, or the employee population is approximately say 5,000. Out of the 5,000 employees, he has approximately 3,000 which are his permanent employees, and 2,000 employees are actually contractors, right? If he needs them, he hires them. Otherwise, he can definitely ask them to go. But these are his permanent employees. I'm not saying Mr. Rahul is not in power of sending by to their permanent employees also. He can, but generally, when firing comes, the number one guys who goes are the contractors, right? If Mr. Rahul doesn't need them, as simple as that. So why I'm telling all these things? Mr. Rahul has something in his mind to share with his permanent employees, but we have contractors also, right? So what is he doing? He want to do a big conference, right? And whenever you want to do a big conference, he will be recorded audio plus video, and this audio plus video is going to be live for all of its regular or permanent employees who are sitting in this building and this building and this building. Maybe 1,000 employees are here. Out of 1,000 employees, 3,000 employees are contractor, and maybe the remaining 700 are the permanent employees. So when Mr. Rahul is sharing the details of how much hike you are going to get, or what is the bonus percentage for you this time, he wants that this information should be revealed to only 700 guys, which are his permanent employee, not to everybody, because this is some confidential internal data. So this is the requirement. How you are going to do that? Believe me, this is just the use case which we have discussed, right? We need to create, and suppose I have 700 employee here, 100 employee here, and 200 employee here. If you add them, these are the 1,000 employees, right? In these three buildings only, which are the permanent employee. And if you choose a path of unicast routing, what you need to do? You need to create 1,000 flows which are going over this network Believe me, 1000, because one flow for one employee. And if there are 1000 employees, then you are creating this 1000 flows which are going to choke your network. Your network can be highly, right, oversubscribed. This is going to have too much of data, too much of traffic, right? And Mr. Rahul doesn't want this. And if he doesn't want this, he has a complete team of network engineers. He's saying, I want the solution of this problem. How you are going to do this, right? And network engineers are saying that this problem is not that big at all. And believe me, under controlled environment, under any specific enterprise, you will see this multicast network. You will see this multicasting, because what we are doing, we are having a group of people. Out of this group, we want to send the message to a specific group of people. We are not doing unicasting. We are not doing broadcasting. Broadcasting means everybody is going to get it. We are just doing the multicasting because we want to send this information, this broadcast, or this message of Mr. Rahul to only group of people which are the permanent employees, right? And you understand what is going to be the problem if you deliver it via unicast or broadcast. As simple as that, right? And if you are thinking that this is not a big problem, I want to showcase you this with a number. I won't take much time, only 4 more minutes or 4 or 5 more minutes. I just want to showcase you how big this problem is, right? Let's say again, we have these two router number one, router number two, and the link between them is 1 gigabits per second. And here is the problem. We need to understand the unit in which we measure data when it is flowing between routers, right? people as people are really confused in it. They say 1 gigabyte per second. No, this is not gigabyte, guys. When we measure speed between routers, it is a common practice to use actually your, just wait a minute, guys. Just wait a minute. Yeah, we can start now. So basically what happened, when we say 1 gigabit per second, the meaning is 1 gigabits can flow in 1 second over this wire, right? Very, very interesting. But people say this is 1 gigabyte per second. No, right? Generally, we use gigabyte in storage or computing power, right? But for the network engineer, it is mostly going to be 1 gigabit per second. And you should understand that 1 byte is equal to 8 bits. As simple as that, right? So you should have this thing in your mind. So suppose I have 1 gigabyte of a file. I'm saying 1 gigabyte. This is not gigabit, right? And you all know, then to send 1 gigabits, we are going to take 1 second. But if I want to send 1 gigabyte, how many seconds are needed? You all know 1 gigabyte is going to contain 8 gigabit. It means that to send 1 GB of traffic or 1 gigabyte of traffic, I am going to need 8 seconds. It means that if this host here in this gray network, host number A, wants this data, 1 GB of file, and you need to deliver it, you are going to need one flow like this, right? And this flow is going to go over this wire. This wire can deliver 1 gigabits in 1 second. Then definitely if I say that there is no overhead here, it means that This data can be delivered minimum in 8 seconds because this wire, to send 1 gigabyte over this wire, we need 8 seconds, right? And now suppose if 10 hosts, whatever the host, although this network contains more than 10 hosts, but I'm talking about only the yellow host, all hosts want the same file. If that is the case, try to understand they are going to be 10 different flows if we use unicast method, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. For one flow, you need 8 seconds. How many you are going to need for 10 flows? You are going to need 10 into 8, 80 seconds. It means that the minimum time this 1 GB file can reach to these 10 hosts are going to be 80 seconds. But now this is the example of unicast. If you want to send this file unicast using the unicast methodology, you are going to need 80 seconds. Believe me, guys, right? But now let's see what is going to happen if we use multicast approach. What is going to happen in multicast approach? We will be creating only one packet. The source of this packet is going to be 10.10.10.10. Destination is going to be magical address where all these guys are listening. It means that from here to here only one packet is coming or one flow is coming. From here to here only one flow is coming, right? Although we need to send 1 gigabyte of data, how many for 1 gigabit we need 8 seconds, right? Sorry, for 1 gigabit we need 1 second. For a gigabyte we need 8 seconds, right? It means that if I say the packet will be reaching here, R2 will be putting it here, and then switch will be replicating here. And suppose switch replication take only maybe 5 seconds. What is the total time? Switch will be delivering it to everybody here. The total time taken is 8 seconds here plus 5 seconds here. If you add them together, it is going to be 13 seconds. What was the time previously when we were using unicast approach? We were having, right? We were having 80 seconds minimum, and we hadn't considered this uh, little bit more overhead here, right? So try to understand if I'm talking about multicast, we are coming down from 80 seconds to 13 seconds. Believe me, we are saving hell lot of time. If we had to solve this problem using unicast, we would have spent 80 second or more than 80 second. But if you want to solve this problem using multicast, it is going to take only maybe more than 8 seconds, maybe 8 to 13 seconds. That is it, right? So as a network engineer, I am pretty sure that you all know about it. But if somewhere it is written 1 Gbps link, it means that it is gigabits per second. It is not bytes. As simple as that. If somebody is written Mbps, it means that megabits per second. I'm not saying that nobody can write 1 Gbps, but if they will write it B as capital. If this B is capital, then it is byte, not bit. As simple as that. So you should understand that why do we having this board here, because this is the most important piece, because we are doing some calculations here, and these are very, very important calculations, right? Having said that, this is what I want to explain you in today's class. Next class, what we will be talking about is that how come on earth the switch which is here comes to know where exactly it needs to send the frame, right? We all know that the frame should go only to the yellow hosts and not the blue ones. How come this switch knows it? And that is why we will be making this switch little bit more intelligent in next class, where we are going to learn about layer 2 multicast. Having said that, let's meet day after tomorrow at the same time for our next class. And now you are open for the question. And believe me, I haven't seen any time that people are not asking question. And today there is no hand raise. It means that I taught it really well, or you already knew all the things, right? Guys, if you have question, please raise your hand, right? Otherwise, am I audible, guys? Oh yeah, Mr. Godwin says yes. So am I audible? Anybody with respect to sound, any problem? I don't think. Mr. Arun has said uh, thumbs up. Mohit ji is saying thumbs up.
No, no.
Perfect, perfect. So see you guys in the next class. I hope today's class is interesting for you, and we will be demystifying. We will be going a little bit deeper into all these concepts. And believe me, multicast, you are going to love it because this is one of the most simple technology. It is, although it is a different style of routing or switching, but it is very, very interesting. Having said that, see you in the next class. Bye for now. Have a nice night ahead.